Hey guys, and welcome to the notes on Latitude Longitude. Today we're going to be talking about Latitude Longitude, and obviously looking at the two pictures here. All right, you may be familiar with this movie or maybe not. This is the actor Tom Hanks, excellent actor, and this movie is incredible because he is pretty much the only actor in the movie for most of the movie. All right, it's him and then this volleyball, which he names Wilson. All right, unbelievable movie. He gets stranded on a remote island. Okay, I guess his plane crashes and he ends up on the island. And the reason why I mention this, well, latitude, longitude, well, that's how you pinpoint yourself on the globe. So if he had some sort of tracking device on him, they could have easily have found him. But in the case of the movie, they didn't find him for a while. So you guys can watch it. It's a really good movie. Very amusing. And he may make you cry over Wilson. I don't know. So you'll have to take a watch and see if you like it. But either way, latitude, longitude is our discussion for today. And so this is my way of doing latitude because this is commonly mixed up by students. So you can take my way, and hopefully this solidifies in your mind. All right, so latitude is a measure of how far north or south of the equator. Okay, so we always look at what our reference line is, and then we measure from that area. So the equator is obviously a horizontal line across the middle of the Earth, and we're measuring how far north or how far south by 90 markings all the way up to the North Pole, and then 90 markings all the way down to the South Pole. And they're going to be parallel lines, and the way to remember it is ladder, okay? Because you climb up the latitude lines like the rungs of a ladder, right? So that's the way I kind of internalize it. And you guys should know the equator is a latitude line, and so are the North and South Pole points on the Earth. There's also the Tropic of Cancer and Tropic of Capricorn, which we'll discuss later in the year, 23.5 degrees north, 23.5 degrees south. Very important latitude lines. All right, years ago, before we had all this fancy gadgetry like your handy-dandy cell phones, okay, your cell phones are actually tracking devices, right? They can actually track your latitude, longitude coordinates, so if the police needed to find you, they can actually do that. But Polaris, star directly over the North Pole, directly over the spin axis of the Earth, also known as the North Star. That's what explorers would rely on. So they would track this star as they traveled, and the angle from the horizon to Polaris will give you your latitude in the Northern Hemisphere. Okay, so if you're traveling northward towards it, obviously it's going to get higher and higher in the sky. If you go south, it's going to get lower in the sky. If you go east and west, it will stay the same altitude. So those are useful little points right there. Obviously compasses will help you with that too, but this is also another way to navigate when the compass is going haywire in really rough seas. Also, Southern Hemisphere, Southern Cross is a constellation that's actually over the South Pole, so that's the one used down there. But in general, without GPS, that's what they used to do. And this is a device called a sextant. What it is basically is a 90-degree angle measurer, and there's a weight that hangs down. And what you do, your eye would look from this side towards Polaris and sight it in the sky. And you would look up at the Polaris, measure the angle, and that's your latitude in the Northern Hemisphere. So that's what the explorers would use. That's what they use to sight their latitude on the Earth. All right, longitude, the other half of the system, these are measuring east and west of the prime meridian. So prime meridian, which actually goes through England, Greenwich, England, and also goes north and south to the North and South Pole, where they actually meet. So they decided to make this system the one that meets somewhere on the Earth, because they have to pick one of them. And it meets at the North-South Pole, which, again, it's not a place where many people live, obviously, or will ever venture to. So that's why they decided to make those the ones that meet. Also, another important longitude line is called the International Date Line. You guys know we are spinning, and our spinning is what makes the day go by, the hours go by. That's what makes sunrise and set. So our time system is based on longitude lines. An International Date Line is the first place on the globe where the date, the calendar date, will change. So if you want to experience New Year's first, you would have to be on the one side of the International Date Line. If you want to be the last person, you'd have to be on the other side of the International Date Line. So longitude lines meet at the poles, and way to remember it, they resemble orange slices on a circular globe. All right, so they get closer together as you get towards the North and South Pole, further apart as you get towards the equator. Okay, without GPS, we could use the sun as our tracker. The sun is at its highest point around noontime. It takes 24 hours for the Earth to rotate 360 degrees. So we can actually know that the sun moves across the sky at 15 degrees per hour. So we can track that along with our movements and using a clock, and we can figure out where approximately our longitude is from the previous hour or hours. Okay, so 15 degrees in one time zone. Time zones are 1 hour apart. So we'll be going over that time system later, but that's the general pattern of it. So based on longitude markings. Okay, so obviously you don't just look at these individually, we look at them together. So you take your latitude markings and your longitude markings and you pinpoint a point on the globe. So we see where they cross, and that's our point where we're located. So let's go over some examples. All right, so here's a quick little example. So I'm going to go over the board. So the first example here, this green dot here shows a latitude longitude marking. Okay, so we always start with our reference lines. Okay, the equator for the latitude markings. So obviously we're below the equator here. So you count 20, 40. So it's 40 degrees and it's south of the equator, comma, we always go with latitude first. And then longitude is next. So this is the prime meridian, so 20 degrees east. Whoops. So 20 degrees sorry about that little glitch. I'm just going to fix that. So 40, it should be 40 degrees south, 20 degrees east longitude. Okay, so that's that first point right there. Okay, here's another point over here. So this is 40 degrees north, and it's 60 degrees west of the prime meridian. Okay, so again, we use our reference lines to pinpoint. And another thing too, also to keep in mind, is the whole never eat soggy waffles thing. So use your little way of remembering northeast, southwest, right, to be able to know what direction we're heading or what direction from the equator or the prime meridian. So keep track of that. All right, you may ask, how do the explorers find Polaris? Right, it actually is pretty hard to find. It's not the brightest star like people think. So we have to find the Big Dipper, which looks like a big ladle, and here it is upside down. Okay. Also remember the Earth spins, so that can change orientation. We draw a line from the end of the Big Dipper in a straight line. From that, you'll actually run into Polaris, which is part of the Little Dipper constellation, which looks like this. All right, so you can see it here. It looks like a little version of the ladle. It's actually harder to find, but that is the where Polaris is located. It's part of the Little Dipper constellation, which is a grouping of stars. Okay, and lastly, also you can estimate once you do find it. So this teacher here is actually citing the angle. 45 degrees, you guys know, is halfway between 0 and 90. Okay, so you could use that as an estimate. So this person is approximately 40 degrees, 5 degrees here. Port Jefferson, our area, we're about 40 degrees latitude. So if you actually look for Polaris, it's going to be 40 degrees above the horizon. Okay, so horizon, remember, is your eye level, every direction. So if you were on the water, obviously it would be where the water beats the sky. And we measure from that all the way up to the star, and it would be 40 degrees above the horizon. So Port Jefferson is 40 degrees north latitude. Okay, thank you guys for tuning in. Hope you enjoyed, and I'll see you next time.